Guys, welcome back. This is 11.2. We're doing installment buying now. We're gonna be skipping a few sections after this and go to 11.5 next. So 11.5 will be Thursday. Next week we'll do 11.6. And then that'll be the last section that's truly new. 11.7 is really kind of a review type of section. So really there's just really 4 sections of new material. 11.7 is kind of putting everything together. We'll have another review and we'll do a small project before the final exam. And then we'll do more reviews again before the final. When I say final, it's really only the chapter test though, like I said, yeah, at the beginning of the semester. A lot of people keep asking me that though, like every week, like, oh, is the final cumulative? No, it's not cumulative. And next week, oh, is the final cumulative? No, not cumulative. It's all good, I don't mind answering. Okay guys, so this is 11.2. There are just a few concepts you need to know. First is add-on interest. This is the interest scheme where interest is added on to the amount borrowed for the loan's duration. What that means is your interest is calculated right at the top, right at the beginning, and that's just carried through the whole thing. So it's really a simple calculation, right? You calculate the interest and then you just pay that in even increments over the whole period. And your percentage rate, that's also called the APR. This is the yearly rate paid on a loan. Knowing the APR is helpful to know if you're trying to compare loans. So for example, sometimes a credit card or something, maybe they'll tell you a loan rate as a smaller fraction of a year. Although I think there's actually a law where they're required to tell you the APR nowadays. Anyway, so they'll tell you a smaller fraction of the year. In that case, you just multiply by the total number of payments in a year in order to find the APR. This would apply to question number 2. So the first one for question number 1, then for question number 2, and then there's one more type. This is when, oh, by the way, so, okay, let's just look at this. Add-on interest is really terrible for the borrower. That's because even though you owe less and less as you pay off a loan, typically with add-on interest, your interest is paid on the entire size of the loan for the entire duration. And so you're really paying a bad interest rate if you think about it. If you know the add-on interest rate R and the total number of payments to be made for the entire loan, that's capital N, different from last time we had small n for compound in a year, right? You can think in a year, typically that will be like a small n amount, big N because it's over the entire period. So it includes the time T kind of hidden in there. And if you know the add-on interest rate, you know the total number of payments, then you can estimate APR with this formula here. You notice that this is an approximate formula. That's because to calculate the true thing is actually pretty long and complicated, but this value is close enough and it's really simple, right? You just take 2 multiplied by that big N that we said, which is the number of total payments, times R, the rate, divided by 1 more than the number of payments total. And this is just the same things restated here. Okay, let's get started with the example questions. So the first page, I have 4 questions of examples. I'm going to show you these, then we'll stop the video and we'll move on to the second page of just more practice problems. Really the same types, yeah. This time I wrote the answers down just to make sure that I'm doing it correctly, because I can make mistakes when I'm typing stuff into the calculator. Okay, so let's do number 1. Make a 6% offer on a Chevrolet Corsica. I'm not sure if I'm saying that right. Just looked at random cars and Corsica came up. I'm not sure what that is. Although one of my students had one of these one year, I remember. Last year, because I only just did this last year. Okay, so make a 6% offer on a Chevrolet that has sticker price of $14,385, dealer cost of $13,378. So the sticker price, actually this is like the MSRP, right? The manufacturer's suggested retail price. You ignore that. That really has nothing to do with your offer. And we're assuming in this situation that you have some inside information or something, or you maybe did some research online to find out the dealer cost is this value. And so when you make your offer, ignore this, and you're just gonna focus on this guy, make an offer off this value. Let's say you don't know this value, then you just assume that it's some percentage less than that guy, in this case, about $1,000 less or something, right? I don't know if that's accurate. I think you need to do some research for your particular car. Okay, anyways, so what is 6%? The way we do that is, let's start by writing some of our things down that we know, our variables. We know that the rate R is 0.06, right? That's 6%. And let's see, the time, Time we're just going to treat as 1 because it's a single time payment, or a single time calculation, that is. And so R is 6%, T is 1. Our P is the value that we're starting with, the principal. That's 13,378. And so all you do is you just say, okay, the interest I pay is going to be 13,378. I can ignore that 1. Let's just multiply by 1, so times 0.06. And see what I get. This is maybe almost overcomplicating things. All I'm doing is multiplying by the percentage. I'm getting 6% offer on the original value. So it's $802 that they're going to make. Now, how much are you actually offering though? Well, you have to take this value and add it to the cost that you had, right? So 13,378 plus 802. So this value, sorry, like this. 13,378 plus the answer from the last part, and we get 14,180 and 68 cents. But to the nearest dollar, it said to answer, right? Where is that? Yeah, to the nearest dollar. So the nearest dollar is 81. So I round this to 14181. This is not exactly equal, so let me say it's approximately. Squiggly equals for approximate, yeah? Okay, that's it. That's the first answer. Right on. Number 2, convert credit card rate to APR. This is super easy. All you do is you just take your 1.25%, which I should first convert to a decimal, 1.25%. If I want to convert to the decimal, I move this twice over, but the answer is in terms of percentages, so that's kind of an unnecessary step. I'm just going to go ahead and multiply this by, how many times? Oh, I was looking at the wrong question. This one. The answer is in terms of percent. This is this is per month. The 1.25 is per month. So how many times per month? 12. 12 months in a year. So 0.25 times 12 is 15. And so I get 15. 15. There it is. Okay, that's number 2. Number 3. Find the APR rounded to the nearest percent. So this is an estimated APR. Purchase a living room set for $3,600 at 12% add-on. Oh, 12%. Add-on interest for 3 years. Ooh, that's not good. Okay, let's see. So $3,600, 12% add-on interest for 3 years. That means we're going to be using, first of all, our interest rate is 0.12, right? And N, remember, is the total number of payments, but it's for 3 years, and it doesn't specify, so we're assuming monthly payments. So 3 times 12, which is just 36. So capital N is 36, and we're just using this estimated formula here. That's APR is going to be equal to, or approximately equal to, 2 times our big N, which was 36, times our little r, which is 0.12, and on the bottom it's big N, which is 36 again, plus 1. Now when you plug this into a typical calculator, you should keep the top in parentheses, so 2 times 36 times 0.12, and then the bottom in its own set of parentheses. Decimals is nice that even if I don't put the bottom set of parentheses, it assumes that I meant it, so it will just allow me to write it in like that. But if you're using a handheld calculator, make sure that you keep the bottom in parentheses. And what I get, it gets me 0.2335, which is, as a percentage, 23.35%, right? But it says to round to the nearest nearest tenth of a percent. So this is approximately 23.4%. The nearest tenth of a percent. Let's shrink this down so it'll fit on one line. There we go. Okay, that's number 3. Sweet. There's one more on the front page. This is the hardest one of the bunch. And let's see, what are we using here? We are going to use, in the first part of the question, no particular formula actually. This one's just straight division going to be? The second one is going to be when we use the add-on interest formula, which is just really multiply the percentage times the principal. Okay, let me show you. Let's just walk through it together. So it says assume the car below can be purchased for 0% down for 60 months instead of taking a rebate. Okay, so there's actually two. If you read ahead, there are actually two things going on. You can either take the monthly payment for 60 months at 0% APR, so there's no interest rate applied, right? You have no interest, and you just pay the original amount. Or you can take a rebate, so that gives you, in other words, a discount. And then after you're taking the discount, then you pay some add-on interest. Okay, so let's see. It says a Toyota Camry has a sticker price of $20,650 with a factory and dealer rebates of $2,000. Okay, so this is the cost, original cost stated, and this is the rebate that you can or cannot accept. It's up to you. Either you accept the rebate and then you pay some interest rate, or you don't accept the rebate and you pay 0% interest. Okay, so first it says find the monthly payment for 60 months at 0% APR. That means no interest is included. So I just take the value at face value, $20,650, divide it into the number of payments to find the monthly payment. Okay, so this first part A, this is 4A. What I do is I take the value of $20,650 and just divide by how many monthly payments. That will give me, let's see, so 20,650. Oh, sorry, 650 divided by 60 is $344.17 to the nearest cent. That's this first value here, yeah? Okay, sweet, that matches. Let's just write it down though. 344.17 to the nearest cent. Okay, part B says find the monthly payment if finance has 2.5% add-on interest for 60 months. So if you do the financing, that means you're taking the rebate. So the first thing to do is take off $2,000 basically. So taking the rebate means that you're not paying the full price, you're paying $2,000 less. So first thing is 20,650 minus 2,000, which is 18,650. Okay, so 20,650 minus 2,000 equal to 18,650. Okay, so what does that mean? That means your P value is, your principal is 18,650. We know our rate is given to us at 2.5, so 0.025. And we know our total N is, total N is equal to 60. Okay, there's something hidden here. The hidden thing here is, remember back to our formula. The formula we're using, we were finding the interest rate, right? Interest rate is I is equal to PRT. If you look at a formula, we have P, okay, we have R, but there's no T. So how do I find T? Well, you have to kind of just think a little bit. There's 60 total payments, right? And it's monthly payments. So how many years is that? Well, that's 60 divided by 12, which is 5 years. So there's kind of hidden in here, the T is 5 years. All right, so let's calculate our interest then. It's going to be 18,650 times 0.025 times 5, because 5 years. Yeah, let's see what that gives us. So 18,650 times 0.025 times 5. That gives us 2,331.25. So in other words, this is how much you're paying in addition to the original cost of the car. Or original cost, meaning after rebates, so this value. Okay, and then, we're not finished though. It says find the monthly payment. So, okay, how do we do that? And there's another step. So this is the interest paid. That means how much is total paid. Total paid is going to be 18,650 plus 2,331.25. So let's do that. 18,650 plus 2,331.25, and that's equal to 20,981.25. Yeah, okay. Let's keep the cents for now because the answer is going to be to the nearest cent. already you can actually compare here, right? Because this is the total price you're going to pay over the long run. And you can compare that right away to what this was here. The cost that you paid without any interest. And you see this, in this case, it's a little higher. Now to find the monthly payment, you just take this value, divide by how many payments you're making, how many monthly payments you make. So that's 20,000 monthly equals 20,981.25 divided by the 60 payments. Sorry, 20,981.25 divided by 60. And you get 349.68 or 69 to the nearest cent. So about $349.69. That's this value here, yeah. One more comment. 20,980 compared to 20,650. Not so different. I mean, it was at a little over $300. These prices, if you look, they're kind of similar, right? So you save like $300. I guess that's not totally insignificant. You buy like a Nintendo Switch, but 5 years is kind of long for that amount of money to accrue. Okay, anyways, next question, part C, says find the APR. So let's take a step back now. We're finding the APR. What do we need? We just need these two values. N is 60, R is 0.025. That's the like APR is really like the true interest rate that you're charging, and then you just multiply that by the number of years that you paid if you're curious for the total percentage that you're paying. Okay, so APR is approximately capital N, or 2 times capital N, which is 2 times 60 in this case, times 0.025, that's the R, right? And then the bottom, it's N again, 60 plus 1. Okay, so let's type that in. In parentheses in the top, 2 times 60 times 0.025, and then divided by 61. And to the nearest percent, so this is 0.049, so that's 4.918%. To the nearest tenth of a percent, 4.9%. That's this value right there. Boom, done. Okay, so last question is just to compare the two. We really didn't need C to compare. We could just compare parts A and B, right? Is 0% better? 0% is this guy, or 2%, 2.5% add-on better? And we just look at whichever is cheaper. In this case, the 0% was cheaper, and so we're going to take that one. That's a better one. Now this might differ depending on the situation. So like, for example, if this rebate had been larger, then this number would have gone down, and so that would have made this the better option, right? So it depends. Sometimes the first one, 0%, will be better. Sometimes the APR or the add-on interest version will be better. Okay guys, that's the first video. I'm going to stop now, and then we'll go on to the problems in the next video. The practice problems. Shoots.